Alright, so in this particular video, for a bird's eye view problem, or aka top view, we have a car that has two forces pulling on it. Here is F1. F1 is given as 420 newtons, and then here's F2, which is diagonally up and to the right, is given as 360 newtons. And this is assumed that the up and right are positive directions, and it says ignore friction. Part A asks us to find the resultant vector, aka net force of the two forces, and then part B asks us to find the acceleration given that the mass of the car is 3,000 kilograms. All right. So in order to do part A, we first have to realize that you need to apply Pythagorean theorem. So here the net force function resembles Pythagorean theorem. Net force square equals net force in the x direction square plus net force in the y direction square. So it does resemble Pythagorean theorem because at the end of the day, we'll reduce all these forces into just one right triangle by adding all the sums up. Okay, so let's go ahead and identify our force vectors first. Here F is in the quote-unquote second quadrant. It goes left and up. Therefore, here I have drawn the component for F1x to the left because this vector here to me is left and up. So hence F1x is to the left. F1y is going to be pointing up. And then I will go ahead and use this angle as 80 degrees. I know the diagram gives this angle as 10. However, I personally like to use the angle that touches the horizontal axis, so I can just do a quick basic subtraction. The angle here has to be 80 because the right angle is 90. 90 minus 10, which is 80. So I like to use this angle that touches, once again, the horizontal axis. It's up to you. You can use the 10 degrees. You just have to switch sine and cosine. Okay. So therefore, I can do the same for f of 2. I need to identify f of 2x, which I like to draw here. F of 2x is pointing to the right, and then f of 2y is going to point up because vector 2 is pointing right and up, aka like northeast, while this is northwest. Okay. Therefore, f2y here is in the red, pointing upward. And then the angle that I'm going to use here is 60 degrees. Once again, this is 90 degrees. 90 minus 30 is 60. I like to reference the angle that touches the horizontal axis so that I can use cosine as x and then sine as y. All right. So let's go ahead and apply our trig function. Cosine at 80 degrees, by definition, is adjacent over hypotenuse. So if I'm using the 80 degrees that I can just calculate here, basic math, 90 minus 10, which is 80. Here, this is the adjacent leg, which is f1x, because it touches the adjacent up to this particular angle given, or particular angle calculated. And then f1 is your hypotenuse, which is the actual vector itself. And the diagram, that vector in the blue is f1, which is the hypotenuse. In order to solve for f1x, multiply both sides by f1. Hence, we have f1 cosine 80, which is equal to f1x. We know f1 is 420. It's given in the statement. F1 here up at the top of the screen is 420 newtons. And then if we punch 420 times cosine 80 in our calculator, we should get a value of about 72.93 newtons. So that is the magnitude of f1x. It's pointing left, so what I just calculated is just the magnitude. To me, it's using common sense to tell whether the vector is positive or negative based on the direction of the vector arrow itself. All right. We can apply the same skill to find f1y. F1y is the opposite of the 80 degrees angle that I'm choosing to use. Therefore, opposite is sine. So therefore, sine at 80 degrees is opposite over hypotenuse. Opposite in this case is f1y. Hypotenuse is f1. To solve for f1y, multiply both sides by f1. So we're doing the same skill that we did down here. So therefore, f1 times sine at 80, which is equal to f1y. f1 is 420. 420 times sine at 80 will give you a value of about 413.62 newtons. Okay. So we found the magnitude of f1x. We also found the magnitude of f1y. Well, let's go ahead and find the magnitude of f2x as well. Here I reduced the work a little bit here. If you kept up with the work on the left side in purple for the f1x, I'm just going to jump right to this line right here. Watch what I'm circling. And so really we're doing the same skill. So instead of f1, it's now f2. We're not going to do cosine, but it's not 80, it's going to be cosine of 60, and that will equal to f2x. So you notice here the work resembles what I did there. So f2 is the adjacent, which I use cosine. What's the angle? 60. What's the hypotenuse? Hypotenuse is 360 because in the wording at the top left of the screen, it says f2 is equal to 360 newtons. So hypotenuse times cosine of 60 is f2x. And if you simplify it in your calculator, you should get 180 newtons. Now, in order to do F2y, same skill. We take the hypotenuse of F2, which is 360, and then we times that by sine. It's sine because F2y is opposite of 60 degrees. Okay, so again, I like to use the angle that touches the x-axis. If you stuck with 30 and 10, your sine and cosine function would just be switched. That's all that is. All right, therefore, F2y, if you simplify this in your calculator, it will be 311.77. Okay. Now that we have our x's and y's all figured out, let's go ahead and apply Pythagorean theorem. So here, in order to find the resultant vector, aka net force, we need to know what our sum is in the x direction and our sum is in the y direction. Well, without overcomplicating it, we have an arrow pointing left, we have an arrow pointing right, we have two arrows pointing up, aka in the same direction. So I'm just going to plug values in. Here, in order to find the net force in the x direction, I need to add up all the stuff in the x direction. So once again, F1x is pointing left. Left would indicate that it's negative. So I highlight that negative sign there for you, because even though I calculated for the magnitude of F1x, when you actually plug in to find the net force, you do need to consider the direction, okay? So here, the purple arrow for F1x is pointing left, hence it's negative 72.93. The f of 2x, which is pointing right, which makes it positive, that's 180. I want to add that together, and then I'm going to square it. Likewise with the y components. However, for the y components, F1y is pointing up along the y-axis. F2y is also pointing up. Because they're both pointing up, they're both positives. So therefore, I'm just going to add 413.62 and 311.77. And then we're going to square that sum, okay? So if you simplify this on your calculator, negative 72.93 plus 180 will give you a positive 107.07. And then 413.62 plus 311.77 will give you a sum of 725.39. And we're going to square that. But visually, it's important for you to understand what's going on here, right? We just found the net force in the x direction. So to me, I know that I can reduce the whole entire system into just one right triangle. Well, I know that this final resultant vector is going to point right, because when you add up everything in the x direction, you end up getting a positive number. Well, the positive number would imply that the component of the resultant vector will be pointing right. Excuse me. Therefore, the same with the y stuff, right? If you add up both of the y components, which happens to be positive in this problem, you get a bigger sum of 725.39. Well, that is positive, so the arrow is going to point up. So the resultant vector is going to go right and up. So this magnitude here is 725.39. Therefore, all we have to do is connect the dots from start to finish, and that is our resultant vector, aka the hypotenuse of a right triangle. So nothing fancy, we're just doing Pythagorean theorem in terms of physics terminology. All right, if we square this and we square that term, and we get 537,654.64. But to find f, we got to square root both sides. So therefore, square root of both sides will get rid of the power here of 2. And then the square root of 537,654.64 will give us a value of 733.25. So what's the net force? Well, the magnitude of the net force is 733.25. But if I read part A properly, it says what is the resultant vector net force here of these two forces? Well, net force is a vector. Because it is a vector, you have to include the direction. Well, how do you find the direction? Well, it's easy. To find the direction is often referenced touching the horizontal axis. So this is theta right here that just came on the screen. Okay, so how do you find that theta? Well, by now, you have your adjacent, you have your opposite, and you actually calculate the hypotenuse as well. So net force here is 733.25. Well, I, once again, like to use tangent, because once you find the adjacent and the opposite, you can just use tangent and get on with your life. Tangent, by definition, is net force in the y direction over net force in the x direction. Hence, rise over run, y over x. To solve for theta, inverse tan both sides. And therefore, all we have to do is plug in the net force in the y direction. Well, the net force in the y direction is this vertical arrow. What is that value? 725.39, which goes in the numerator. And then what is net force in the x direction? 107.07 here, and that I'm highlighting in purple, okay? And that's positive, this is positive. So therefore, I know my angle has to be pointing north east. Okay. So if you calculate your angle properly, you should get a value of 81.6 degrees. Therefore, my overall final answer is net force, the resultant vector, is 733.25 newtons. And then that is 81 degrees above the positive x-axis. Or you can say 81.6 degrees northeast. That would be the proper way to express the net force there. Okay. Now, part B says, if the car has a mass of 3,000 kilograms, what's the acceleration? Well, net force equal to ma. To find a, divide both sides by m. So net force over m, which gives you a. We just found net force here, which is 733.25 newtons from our work in part A. The mass is given as 3,000 kilograms. Simplifying that will give you a value of 0.24 meters per second squared. But once again, I don't see the word magnitude being used, and acceleration is a vector. So therefore, you need to include the direction. The direction in this case would be the actual angle, and the angle for A is the same as the angle for net force, because net force and acceleration shares the same direction. F follows A follows F. So whatever the direction for F is, A has to have the same direction, okay? So therefore, the angle for this one is also 81.6 degrees above the positive x-axis, or 81.6 degrees northeast. So the proper answer for the whole entire thing would be 0.24 meters per second squared, 81.6 degrees above the positive x-axis. So the car is going to veer to the right and up because the force here to the right and up is larger. All right. Other than that, I hope that helps. Stay nerdy. Don't be whack.